BlenderTek.net, a division of BlenderTek.com again. In this episode, we're going to continue powering our way through the base weapon blueprint so that we can get some machine guns going on this Jeep and we can blast through some people, and the associated functions in the player controller and base character classes. A quick aside, and I know my asides get quite long. I know a lot of people go, man, this is so boring. When can we do something fun? But programming can be boring sometimes, and while I try to speckle the odd different thing in between episodes, such as the Jeep episode, I try to use blueprints as close to as real programming languages as possible, much like C++ or Java. So you have to compare it with, say, making one huge main class in one of those languages being the same as a giant event tick blueprint versus creating a ton of classes in one of those languages with inheritism and polymorphism and such. And you must ask, what's more powerful, making a one-off blueprint or using functionality that can be reused and edited with ease? This is a problem I see with a lot of people that take stab at blueprints with no serious programming background. So with that said, open your project and remember, create your way. So in the last episode, we went ahead and we created this little Jeep that we could enter, and then destroyed the character, which was temporary, and then we could exit. So that was something different to do. But yeah, I want to put some weapons on it, so we are going to go into our weapons folder and open our BP a weapon base class. And remember, we left ourselves this big red note that said need to do set weapon state function here because it's about as big as this one. This is determine weapon state. Now we need to be able to set the weapon state. We need to set whether we're reloading or whether we're idle or whether we're firing and so on and so forth. So I'm going to delete that. And yeah, we're gonna get right to it. The first thing I'm gonna do is I'm gonna select this function, however, and I'm gonna put it in the states category. State is what we were using because we're gonna have lots of functions that have to do with state. And then all we need to do is we need to drag in our local variable new state as a getter because we're gonna need that for the next function that's gonna be used there. So let's create a function called set weapon state, and just like the other one, it's going to be in the state category, and it's going to have an input which is going to be the new state, and that is going to be of the type weapon state. Let's just compile that quickly and go back here, and we can now drag that in. If we go to state and set weapon state, where are you? There you are. We can drag it in. We can connect that right up. And now this is ready to go. So finally set the state once state is determined. Alright, so this function is done. I'm gonna compile and save it. And I want to close all these other windows in the meantime just because I'm recording and because they confuse me. So we are done with that. We're on to set weapon state. So the first thing we're going to need in this function is a local variable. Just one this time. And that is going to be L underscore previous state. And that is going to be of the type, you guessed it, weapon state, and by default it's going to be idle, so that's fine just the way it is. And while we're here, I just realized we might as well add it. We're going to need an event dispatcher called on weapon picked up. That's going to be used throughout all weapon classes, so we're going to need that event dispatcher. So we're going to take our new state. It's going to need to be well, I need to set up I had a hard drive crash. I need to set up my hotkeys quick. So while that's downloading, I'll just go manually. New state, we want to reroute up and down. And technically across as well. And then what we're going to want to do is we're going to want to take our current state and we're going to want to set our previous state. So obviously whatever our current state is what our previous state is going to be. And then we're going to set our current state to something new. I kind of dislike that going through there, so I'm gonna bring it down, and I'm gonna take this one and bring it straight down so that it doesn't look as ugly. This is kind of a ugly setup here, but whatever. And then we're gonna want to go into a sequence. I should have moved this first. So yeah, we'll go into a sequence, which will have 2 pins and 0. So the first part of the sequence, we're gonna go into a branch, and this is gonna be for debugging. Remember, we debugged for determining state, which could be enabled. We're gonna do that for changing the state too, because it can get very complicated. So its condition is gonna be the exact same one. The where is it? It must be under config debug. Yeah, B print determine weapon state info. We're gonna duplicate that, however, and we're gonna do it for set. So I'm gonna duplicate it. It's gonna be exactly the same. It's just gonna be, instead of determine, it's gonna be set. That way we can debug each one on the fly if we need to. So that is going to be our condition. We can close this big config category again, like so. Alrighty. And so if true, what we're going to want to do is we're going to print a string. So we'll do a print string. And we don't want to print to log since it'll just be debugging. And we're going to want to do an append. I need to set my keyboard shortcut for straighten too, just so you guys, if you're interested in how I do that, go to keyboard shortcuts, and I believe it's under, where are you? It's not under Blueprint Editor, I don't believe. Nope, it's under Full Blueprint Editor. No, come on, which one is it under? How come I can never find them? Graph editor, that's it. So, straighten connections, type a new binding, Control-Shift-S I like. So there we are. So I can now Control-Shift-S that and straighten it out. So yeah, we're gonna want to do an append, and we're gonna want A, B, C, D, and C is gonna be a tab, 1, 2, 3, 4. New state, colon, space. A is going to be setting weapon state to colon, or setting weapon state period previous state equals, or we'll go colon, previous state colon space, and then that'll be our previous state. So L previous state goes into B, and it'll convert it, and then our new state will be the new state that we created this reroute for, like so. So we can even bring that right up like so. Awesome. So we'll straighten this all out. Let's see if we can't fit this in here. So this right here is debug print strings for setting the state if boolean is true. All right, and then under 1 is where we actually set the state. So this is going to go into a sequence, And this sequence is gonna have 12 pins. It's 13 technically. There's no easier way to do this that I'm aware of, so we just have to power through it. And we're gonna need 2 macros for this as well. So we're gonna need to create a new macro called did state change from. And we're also going to need one called did state change to. So that's how we do our checks between the different states. So let's start with did state change from. So it's going to need some inputs and outputs. So the output is going to be a boolean called b state was changed. The inputs are going to be previous, or we'll go state priv, whatever, close enough. State new, and state compare, state to compare. I hate that that's longer, but that's about whatever. Comparison state, no, there's no shorter way. Anyways, these are all going to be e-weapon. I should have set this for states. E-weapon state, e-weapon state, like so. Alright, so before we get to the output, it's actually fairly short. We just first of all check if the previous state is equal enum to the state to compare, and then we do an and boolean. And we'll bring this one up, and not if new is equal to compare. So we're just checking if the previous state is equal to the state we're comparing, but it's not equal to the new state. So we'll just set this all up here. And plug it into the output, and everybody's happy. Alright, so compile and save. And then we have did state change to, and actually I'm going to delete it because it's so similar, and I'm going to duplicate this, and then I'm going to call it change to. I'm going to close from and open did state change to, and this one is exactly the same except we just compare it in reverse. So let's just delete the first pins and take our and not here. So we want to check did new compared to our state to compare, is it equal, and not state compare equal to the previous state. So it's just the inverse. And we'll do the same thing. We'll just kind of combine it together here. Good enough. Compile. Save. We can comment this if we want. Compared to state to compare. Whoops. Is previous not equal to new, while new still equals state to compare. Not the best explanation, but it'll work. Let's comment, paste. Oh, that was the wrong way to do that. Compared to state to compare is new or not equal to previous. Well, previous, you can always go through and make your own comments at a later date to make everything make more sense. But now that we have those macros, we can start working on this set weapon state function, which is also fun. So we're gonna have our reroute pin sitting here, and we're also gonna need our L previous state for every single one. And so what we do is we come in here and we do did state change from. So, and then it's a macro in the middle, which goes into a branch, and that's its condition. So each one connects up to a branch like so. So did state change from, we're comparing to winding down. Previous state is previous state. State new is going to go into the pin here. B state was changed. I want to make that a lot shorter. So let's just go did state change from, we'll just say yes. It'll either be yes, true or false, or yes, true or false. So let's change both those to yes and compile. That should make it a lot shorter. A little bit shorter, I guess. Alrighty, so and then we'll need a bunch of functions on the true, but I'll wait for those. We'll set this up first. So yeah, we're just gonna do that over and over. There's some that'll be did state change to, so pay attention. However, we'll have 3 of these ones, so let's just do 3, I guess, while we're at it. And previous state goes into previous on all of them. And new state goes into new state on all of them. And we'll go winding down, winding up, and firing. There's 3 main states there. Let's go to a branch, conditions. As you can see, this gets pretty messy. So after those ones, then we do 4 did state change to. So 1, 2, 3, 4, and we'll need 4 branches for that. Condition, and 3 and 4 and 5 and 6. I wish I could close some of these windows, but there's a bug in 410 that you can't change your layout. I'd like to use small toolbar icons, but I want you guys to be able to see. Anyways, so previous state is always going to be previous state. In fact, I might bring it out here. It'll make things a little bit more confusing looking, but although actually yeah, no, that should be fine. And state new comes up from here. Alright, so what we're comparing is did state change to winding down, winding up, and what's the opposite of firing? Holstered, as well as holstering. Right there. Then we have 3 more did state change twos. Just gonna bring these up. So did state change to 1, 2, 3. Let's just set these up over here. So after holstering, it'll be equipping, and then it'll be throwing, and then it will be dropped. And then we go back to did state change from, instead of to dropped, from dropped. And the last, or after that, then we set the current state. Just remember, we're setting the state here. So we're gonna set it to new state. So we can take this one down here. Yeah. So this one can come down to here and plug in. And lastly, we do a check, did state change to firing. And previous is L previous state, and state new goes all the way back up to new. Let's connect all these news up. State new, state new. Oh, come on. State new, state new, state new. All right, let's bring these up. And we'll need branches for them, so I'm just gonna make a couple here and then copy and paste them. So we'll go branch, 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 one more branch. We'll put a space there because we know that we have that set. And then state state previous, let's just connect that up, just keep things cleaner. State previous, state previous, state previous. And this one can come way up to, well, I can stay down there a bit. So these can all come up, keep things clean. All right, so 7 goes into that branch, 8, 9, 10, 11. Ooh, I think I might have screwed one up here. Yes, I have one too many branches, so I have to figure out where it is. Oh, I see. I accidentally threw in an extra branch here. Okay, so we just have to hit Alt and get rid of all those. Bring them all up. Connect them up. 7, 8, 9, 10. And then 11 is set state. And then lastly, we do one more check on this branch here where we check if it changed to firing. Now we need to make all the true functions. So let's compile and save while we're here. So the first one is going to be, I don't believe we've created, wind. No. So we're going to need a new function called onWindDownFinished, and this one has no functionality. It's just there to set the state, so there's absolutely no logic. So onWindDownFinished, it's just so that we can call that function when it is finished. So this is under events, so we can close that and we can call it like so for true. On wind up finished is very simple, so that's the next one. And I might as well just duplicate this since it's in the same category. So on wind up finished. So we'll call that on true here. Remember, this is winding down and winding up if you look at it. So let's open that up, and all we do in here is we clear timer by handle, and that handle is, let's see if I have it here, handle get handle firing. timer handle. Yep, that one right there. Perfect. Easy peasy lemon squeezy. So just compile and go back. That one's done. So the next one is on weapon fire finished. That is a custom event, so we need to go to our event graph, and I'm gonna create a new graph called weapon state graph. If you remember, I like to have as many graphs as possible to keep things clean. So I'm gonna create a custom event called on weapon fire finished. And so what we do here is we go into a branch, we check, is this a dedicated server? If true, we stop simulating weapon fire. If false, we clear timer by handle. And we also do that from true though, and that is again the handle firing timer handle. And then lastly we set, and we don't have this variable, I don't think. Nope, so we need to create a new boolean called b refiring. Is the weapon firing again after we fire a shot, is all this is checking, so that's a boolean. Default category not replicated, it's false, but it does need to be transient, so we set this to false. So yeah, all we're doing here is let handle firing know the next shot isn't refire. So yeah, all this does is clears any visuals associated with the last weapon fire, the last weapon shot fire. We'll just leave it as shot. So let's go back to set weapon state, and we're gonna call that. So that is on weapon fire finished. I'm gonna run out of room here. The next one is on wind down started. So same thing, let's go to our well, we can just do this one on wind down started. Let's call it. Make sure it's the right one. Wind down is this one here, winding down. Yep, so on wind down started. So what we do here is we set start wind time to get game time in seconds. Get game time seconds. And then we set timer by function name, since we can't do delays in here. And that function name is handle firing. It does not loop though, and the time is wind down time. So it's basically how long before we can fire, basically how long before it's wound down and where we can handle firing again. And we take the return value and we set handle firing timer handle. If you ever wondered what those return values were for. I just need to make sure that we have handle firing created. Let's do a search here. Handle firing, we do not. So we need to create that. And that's one great big function in itself, so we're gonna have a lot of fun with that. So let's create a new function called handle firing. It's in events. Has no input and output, but it is one giant function. So first we go into a branch and we check if current state is equal to winding up. Because everything just ties together here, and once you're done, everything's just functional because everything's so tied together. Just putting it together piece by piece, and once the last piece is in place, there's no tweaking, no nothing. It just works, and then it can be modified to your own needs with child classes. So we check if we're winding up. If true, we go into another branch, and that condition is get game time in seconds. We basically want to know if we're done winding up. We take that minus start wind time, and we check if that is greater than or equal to wind up time. So whatever this weapon will be, a child class, it's wind up time. We check if that is. So basically, whoops. Are we done winding up? If true, then we determine weapon state. So if done winding up, go to wound up fully. Actually, I'm gonna put that in there just to keep things clear, because that's what we called it. If false, then we need to continue winding up. So then we set timer by function name. That function name is this one, handle firing. We basically just loop back over this function. The time is going to be a float minus float, which is going to be wind up time minus, come on, get game time seconds minus the time when we started winding up, start wind time. So that minus that. Good enough for now. So if not done winding up, continue winding up by looping the function again. And then, oh yeah, we need to set handle firing timer handle in there as well. If we're not winding up, however, so if false, let's create a reroute here. We'll do a reroute. So this is all right here. This is all if weapon is winding up. I'm gonna take the input right there. All right, so the next one is for winding down. So let's reroute over here. Bring that down. So what we do is we go into a branch, as you might have guessed. And we check if you might have guessed also current state is equal enum to winding down. That is our condition. If it is, we go into a branch and we do the same thing over here. So I'm actually just going to copy it and paste, go into the branch, except instead of wind up time, it's wind down time. So just replace that. So wind down time. So basically, are we done winding down? If we are, then we determine the current weapon state. If we're not, we do the exact same thing over here. I'm gonna just paste it in. And again, we're just gonna take wind up time with wind down time. So get wind down time. So if not done winding down, then continue winding down by looping back into a function. Yeah, that's that. If false, we go into a sequence. So that's the only two that we need right there that have to do with winding. So if weapon is winding down, I'm just going to compile and save while we're at it. And in that sequence, I'm going to drag it all the way up here. We handle the weapon firing, and we also happen to handle the weapon logic after firing. So first of all, we're going to go into a branch way over here to leave us lots of room to work with. Actually, let's do it over here, keep things clean. Its condition is, can this weapon even fire? So we do an AND boolean. Can fire, and we go into an OR boolean. Has infinite ammo if the server has set that, or if the weapon has set that. You know, like I said, certain vehicle weapons. We also check if an int is greater than 0, and that is current ammo in magazine. Replicated. Can weapon fire? If true, then we go into another branch, which condition is dedicated server. And we fire the weapon here, and if it's a dedicated server, there's no reason to play the effects. So if false, we simulate fire, which we haven't done yet, so we need one more function. Yeah, we're gonna need quite a few functions here. So the first one's simulate fire, which is huge in itself, so I don't know if we're gonna get any of this done today. In fact, I know we won't. So let's create a new function called simulate fire. Again, has no inputs and outputs, but it's very huge. So first we go into a branch, and its condition is a not boolean and boolean, and then the bottom of the and is a not boolean. And we take the current state and we check if it's equal to enum firing. So are we not firing at this current frame, or when this function is called? Simulate fire also should be under visuals. And we want to know, authority. Do we have authority? Does this actor have authority to simulate fire? So the whole reason this branch is here is basically we don't do any effects or any logic if this isn't a remote call and we aren't firing. So that's the has authority and not equal to firing. So if true, so if it's not all that, then we go into a sequence which is going to have 4 pins, so 3. It's going to go to 3. First, we want to see if we're properly set up to actually show the muzzle flash. So we're going to go into a branch, which is going to have an and boolean. And I'm going to need more space, most likely. So first we check, we don't have any of this created, I don't believe. We do have our muzzle flash particle system. That's good. Okay, even though I haven't created one yet. So we want to check our muzzle flash particle system, and we want to make sure it is valid. So is the particle system actually there? And then we do another is valid, and we're going to do this on a pure function, which we haven't created yet. I don't think. Oh yeah, get relevant weapon mesh, perfect. So just pull that in. Since it's pure the mesh out, we want to make sure the weapon mesh is valid and that the muzzle flash particle system is valid. So that's what this does. So we check if those are valid. I'm gonna leave these lots of room. So basically, is weapon set up to show muzzle flashes? If true, we check if we want to loop them or not. So we go into another branch. And this one's condition is we go into an or boolean. And each of these goes into a not boolean. So this one is B loop. Ooh, do we even have that? Let's see here. Muzzle. I thought I created that. Yeah, B looped muzzle flash, not that condition. So we want it not true. And then we want the muzzle flash particle system again. And we want to see, is it valid? Technically not valid. Do we currently not have one playing? Because we don't want to fire one at the same time if one's already firing. Basically, if we don't loop the muzzle flash, or if we loop it but currently don't have a flash spawned. So if that is all true, we go into a to and sequence, and we want to check if our owning pawn is valid and is locally controlled. This is all different on server side, obviously, so that's our two ins. If true, we go into a sequence. And we're gonna need to get relevant weapon mesh. We want to check if that is equal to first person mesh. And that condition is going to go into a branch, which is going to be the second pin here, number 1. And if true, we want to spawn, we finally get to the effect, spawn emitter attached. So the emitter template is going to be our muzzle flash template. Which I need to create, so that is a particle system reference. So we're gonna need a new variable called muzzle flash particle. That is going to be of the type particle system reference. We haven't created one yet, but we want it to be editable. It'll be under config effects. Won't be replicated, of course. It'll all be handled client side. So that goes into the emitter template. The component we want to attach to is third person mesh. The attach point name is going to be the muzzle flash socket, which we haven't created either yet. So let's create a new variable called muzzle flash socket. This is going to be of type name, not editable, sorry. This is going to go under config effects as well. Doesn't need to be replicated, doesn't need to be transient, but we do need to compile F7 and give it a name. Every weapon where the muzzle flash is going to be from is going to have a socket called muzzle flash. So we take that and that goes into the attach point name, and then location, rotation is fine, snap to target, keep world scale, and be auto destroy. And then we want to take the return value, and I'm gonna rename this PSC. I'm gonna duplicate it because we're gonna have muzzle flash PSC secondary. And that'll be a particle system component. Yep. So we're going to set that to the return value. And then we're going to take that value and we're going to set only owner C to false. And then we're going to take that again. We're going to reroute. Then we're gonna set owner no C to true. Alrighty, cool. So that half is done. Now we need the top half. I'm gonna do the same thing again, basically, just without the branch. So we spawn emitter attached. Muzzle flash particle is the emitter template. And it's gonna attach to the relevant weapon mesh. The attach point name is gonna be the muzzle flash socket. Location, rotation's fine. We want it to be exactly where that socket is, but we want to snap to target, keep world scale, auto destroy, yes. Then we want to set our primary muzzle flash particle system component to the return value. And we go into a branch. The condition is get relevant weapon mesh and see if it is equal to first person mesh. If it is, then we set this to set only owner C. We set that to the condition there. And that's only if it's true. Let me actually put this down here to keep it cleaner. All right, so that is those. So what this here does, after actually all this here, this entire sequence, so I'm gonna move this over since we have lots of room. So this handles split screen for locally controlled pawns. Gonna compile and save while we're at it. So that handles muzzle flashes for locally controlled pawn. Now we need to spawn them for non-locally controlled pawn. So that's the false here. So the false is gonna go into a spawn emitter attached. We're gonna have the muzzle flash particle and the muzzle flash socket, and relevant weapon mesh is going to be needed. So let's so mesh out goes into the component we're going to attach. Muzzle flash particles, the template, the attach point is muzzle flash socket. So that goes in like that. Location, blah blah blah. Snap to target, keep world scale, auto destroy. Then we set our primary muzzle flash particle system component to the return value, and that is that. So on this here, bring it over some more. Spawns muzzle flash FX for non-locally controlled pawns. So I think we have that complete. So if we have a locally controlled pawn or don't, as well as generating split screen, let's put this in caps, spawns muzzle flashes. All right, so that's the first part of the sequence. And then number one, so the next part is we play the fire animation. So we are gonna reroute, and we're gonna go to a branch. And its condition is going to be an OR boolean, and which is going to have a not boolean on top and bottom. And top one is going to be B loot fire animation, and the bottom one is going to be B playing fire animation. There we go. Like so. If true, then we play weapon. We don't have it yet. And play. No, we don't have it yet. So that'll be another new function we need to create, play weapon animation. So let's create that. New function, play weapon animation. It's gonna be in visuals. It's gonna have an output, which is gonna be a float, which is gonna be the anim duration. And it's going to have an input, which I don't believe we've created yet, which is the structure for the animation, because each weapon is going to be different, so we can't just put it in a variable there. And it's going to be different for first and third person. So we need to create, oh yeah, we did it okay right there, swep animation, perfect. My bad. So we have an input called, whatever you want to call it, basically just in wep anim of type s_wep anim. So what we do is we're gonna need to reroute this one down. Basically we take our owning pawn and we do an is valid check, non-peer. And And if it is valid, I don't believe we have a function for him yet either. Let's see, play weapon animation. No, so we're gonna need we're gonna need a function on him too. So yeah, we'll compile and save where we're at here. We'll run over to our blueprints and BP base character, and let's create a new function called play weapon pawn animation. It's gonna have an input called montage, which is gonna be swep anim. It's gonna have an output float just like the other one, which is gonna be anim duration. This is gonna be under weapons. So we're gonna go into a sequence. Yeah, we'll finish this one off for today at least. We'll have 3 pins there. This will need to be rerouted and then broken, so break. We're gonna return down here. That'll be the last part. And we're gonna need a local variable called out anim time. So L anim time out. That's gonna be of type float with a value of 0. So that'll be what we output. So we want to, I don't know if we have the actual, I guess it would be mesh 2p. Yeah. Well, we can always change it later, but we want to get anim instance. I'm gonna assume it's mesh 2p. That'll be the arms in the first person view. I don't think oh yeah, we do have those set up. So that is, yeah, mesh 2p. Okay, perfect. So we get the anim instance. Oh, we're gonna need a macro for this as well. I don't think we have it. We do a both valid, no. So we need to go to our BPM helpers, and we need to add a new macro, both valid. This checks if 2 objects are valid. So we have an input, or let's do an output, be both valid, and then we just simply go to object reference, obj obj2, and we check is valid, is valid, and then we do an and boolean, and if they're both valid, well, you guessed it, they are both valid. So then we can plug that right into there. So let's save that. Let's go back to our base character, and we want to take this and do a both valid check. That's object 2 is pawn first person animation, which I'm going to reroute because we're going to need to use it again. So we'll reroute it down here. We're also going to need this anim instance down over here. And this goes into a branch. And if true, we do a montage play, or play anim montage. No, so we have to take this here and do montage play. There we go. And the montage to play is the first person, pawn first person animation. Yep, play rate is 1. Then we take the return value and we set L underscore anim timeout, but only after we also set it up here, and then it comes down and we go into a gate, and this closes the gate up here because we can only do one, either first or third person. This one enters and exits, and we don't start closed. So we can go back a bit now. We do a montage play and branch, and both valid up here as well, so we can just copy those, line this up, plug it in, return value. The montage to play is going to be the third person animation, and that is also going to be object 2 here. Object 1 is going to be get anim instance mesh. That'll be our third person, I believe. So basically then it's just this branch plugs into number 1, and this branch plugs into number 0. So what we're doing here is fairly simple. I'll give it a good comment since it can be confusing. It plays a weapon driven animation for both the third person mesh and first person mesh, so that they are both in sync. They will always be in sync unless your third person and your first person animations don't match. But we can compile and save that now. Where do we have an error? Oh, I forgot to plug in target anim instance. That is up here. Compile. Save. You can see there's so much inheritance, it gets to be a 3-second compile. So now we can go back to our base weapon. So our owning pawn, we can now play weapon pawn animation. The montage is in wep anim only if valid, like so. I prefer to bring it up so it's a little bit clear. There we go. And then we need a local variable called L used anim duration, which is going to be of type float. So we then set that to anim duration. Then we go into a sequence. This is going to have 3 pins, so 2. We're getting quite long again, so I'm actually going to leave this for next time. So let's just compile and save where we're at. So next time we will finish this and hopefully get set weapon state finished. Not all of these are as long and convoluted as this one is, but when you're setting a weapon state, some of them can be, because this involves firing weapons and reloading weapons and such. And I can tell by the amount of variables and the amount of functions that we've created. Like, look at how many functions we've created. It's got to be at least 15 or 20, that we're getting at least 50% or more done on the base weapon. And once the base weapon is done, we can create any weapon we want by just going into the class setting or the class defaults and just setting all our variables. You know, how fast does it fire? What's the muzzle velocity? What's the size of the bullet? The caliber. And then we can create any type of weapon we want as long as we have the animations for it and the mesh, obviously. So yeah, just save everything, and thanks again for watching. If you learned something, please like this video and subscribe as well. We also take donations at paypal.me/BlenderTek. If you dislike this video, please tell us why. So we'll see you next time. Remember, create your way.